Okay, good morning, ladies and gentlemen. Okay, this is Professor David J. De Los Reyes. The date for this morning will be January 27, 2024, and the time is 1:13 a.m. Okay, my topic for this morning will be, I think this will now be the last part of my long video format topic, trigonometry. And this is lesson number 52. Since lesson number 52 will be the last topic, this refers to the so-called inverse trigonometric function. Maybe I could add up two more topics by just giving you example problems on the solution involving inverse trigonometric function. Okay, let's proceed. The subject matter for this morning will be lesson number 52, and the title of the topic will be inverse trigonometric function. Inverse. If originally we are given the sine, cosine, and tangent, these are the so-called trigonometric functions. So for this morning, we will be having the so-called inverse. And if we see inverse, there should be a power -1 over here. -1. That's the meaning of inverse. So if we now try to bring out the so-called notation when we see inverse trigonometric function, it will be something like this. Notations. Arc sine of angle x, okay, this can be written as sine to the -1 of x. This is now the one I'm telling you. Sine to the -1 of x is actually an inverse function. Okay? So, arc sine of x, this can be written as simply, they are equivalent. Sine to the -1 of angle x. And if we try to read this one, it will be the so-called the angle whose sine value is x. If we try to read this, it is the angle whose sine value is x. So actually, sine to the -1 of x is actually an angle. Okay? It is an angle. Similarly, arc cosine of x, angle x, this can be written as cosine to the -1 of x. And if we try to read this one, it is the angle whose cosine value is x. So this is also an angle. Right? The third one, arc tangent of angle x, this can be written as tangent to the -1 of x. And if we try to read this one, this can be read as simply the angle whose tangent value is x. So actually, this is also an angle. Okay? That's how we read this one. So it refers to the so-called inverse trigo functions. Originally, without the -1, it is just simply the trigonometric function. Sine of x, cosine of x, tangent of x, secant, cosecant, and cotangent. But if there is a -1 here, there is a -1, it should be inverse. Okay, let's try to bring out another equivalence under inverse trigonometric function. These are concepts which are needed in the computation of inverse trigonometric function. the sine of the open bracket, sine to the minus 1 of x, close bracket, this should be equal to, it is equal to x. Just remember this. The sine of the arc sine of x is equal to x. Second, cosine of cosine to the minus 1 of x is also equal to x. And the tangent of tangent to the minus 1 of x is equal to x. These are all inverse function. Inverse. Okay, inverse function. Inverse function. Inverse function. That's why our topic for this morning is inverse trigonometric function. We should remember these three here. There are three more, like the cosecant, okay, the secant, and the cotangent. But I just wrote three here. That is the sine of the arc sine of x is equal to x. And the cosine of the arc cosine of x is also equal to x. And the tangent of arctangent of x is also equal to x. So these are only the needed concepts in the so-called study of inverse trigonometric function. At least we now know the notation of inverse trigonometric function. It is red arc sine, or simply sine to the minus 1. Arc cosine is just the equivalent of cosine to the minus 1. And arctangent is just the equivalent of tangent to the minus 1. Plus these three concepts here. That is, the sine of the arc sine of x is just simply x. And the cosine of the arc cosine of x is just also equal to x. And the tangent of tangent to the minus 1 of x is also equal to x. Okay, let's try to bring out an illustrative example using these concepts here. These three concepts. These are just notation, but the three most important concepts under inverse trigonometric function are these three here. Okay, let's try to bring out an example problem. This is now the last topic under my long video format trigonometry. So I will add up two more lessons maybe, then that's it. Then I will discuss another long video format topic. I will what do you call this, announce it on the last part of the lesson. Okay, let's try to bring out an example problem. Evaluate the sine of open quantity to the arcotangent of 2. This arcotangent of 2, this is actually, I didn't wrote cotangent there, but there are actually three. This can be written as cotangent to the minus 1, right? Arcotangent is just the equivalent of cotangent to the minus 1. It is same as this one. I just wrote 3 here. It follows that if it is arcotangent, it should be cotangent to the minus 1. And the problem is asking here, what is the sine of twice the arcotangent of 2? This arcotangent of 2 is actually an angle. Right? An angle. And it should be multiplied by 2. And the problem is asking that angle, multiply it by 2, and if we try to take the sine value of it, what will be the value? It is something like that. Okay? So at least we know how to analyze this problem here. The arcotangent of 2 is actually an angle, and it should be multiplied by 2. That's given in the problem. And the problem is asking if we try to multiply the angle by 2 and we take the sine value of it, what will be the value? Okay? This could come up maybe on the so-called SAT or CAT exam. It is just like the so-called algebra problem. It's an algebra problem. The unknowns are x and y, but in here, the unknown are also x, but it is in terms of the so-called inverse trigonometric function. Okay, let's try to bring out the solution. We will let x equal to arcotangent of 2 is an angle, right? So for the meantime, we will let that arcotangent of 2 to be equal to x. So actually, we must have to solve for x. Okay, so this is a representation, right? Then after that, we'll try to divide all terms by 2. I will remove this cotangent first. Okay, x is twice arcotangent of 2, right? Then I will try to remove this 2 on the right hand side, so I will try to multiply this by 1/2, right? So x times 1/2 will be x over 2, and twice the arcotangent of 2 times 1/2, these 2 here cancel with this. So this is now x over 2 equal to the arcotangent of 2. We eliminated the coefficient of the right hand side. Okay? And to solve for x, okay, we must have to eliminate this arcotangent here. And the enemy of an arcotangent is actually cotangent. So we will take the cotangent of both sides. So actually, the cotangent of open bracket x over 2 equal to arcotangent of cotangent over 2 close bracket. And if we try to expand this one, the left hand side, the cotangent of x over 2 will be the cotangent of x over 2 equal to the cotangent, okay, of cotangent to the minus 1 of 2, okay. Arcotangent of 2 is just the equivalent of cotangent to the minus 1 by following this, right? Okay, and by following the next concepts here, okay, the cotangent of minus 1 of 2, it will just be simply 2. Because there are 6 over here, I just wrote sine, cosine, and tangent. So there should be cotangent, secant, and cosecant. For the given problem, it is a cotangent. So it seems we replace this one by a cotangent, and this one will be cotangent to the minus 1. Okay? So by following this rule here, the cotangent of cotangent to the minus 1 of 2, okay, will be equal to x, but the right hand side is, the angle here is 2, so it will be simply equal to 2. You got it, guys? Okay. The cotangent of open bracket x over 2 of arcotangent of 2, if we try to expand this, the cotangent of x over 2 will be the cotangent of the total angle x over 2 for the left hand side. And for the right hand side, the cotangent of arcotangent of 2, this can be written as cotangent of cotangent to the minus 1 of 2, it is this. Okay, it will just be simply the given angle. Right? Cotangent is the reciprocal of tangent, right? So cotangent of x over 2, this can be written as 1 over the tangent of x over 2, and this should be equal to 2. Okay, this is actually all over 1. Then we try to cross multiply this. Therefore, tangent of x over 2 should be equal to 1. We put this 2 underneath. This is 1 over 2. We are solving for tangent of x over 2. We put this 1 over here, then we put 2 underneath. So tangent of x over 2 should be equal to 1/2. X over 2 is already an angle, the one we are looking for. So if we try to draw a right triangle in which the angle is x over 2, okay, and the opposite side is 1, and the adjacent side is 2, because tangent is opposite over adjacent. So meaning to say, if tangent of x over 2 is equal to 1/2, the resulting right triangle, this will be 1, this is 2, and the hypotenuse will be Pythagorean theorem, right? The square of 2 plus the square of 1, so the hypotenuse will be the square root of 5. Okay? Let's try to take the sine of this angle here. The sine of x over 2, we know the definition of sine, right? It should be opposite over hypotenuse. So this is 1 over the square root of 5. Okay? So we are now given this, this is a trigo function. It is not inverse because this is just simply sine, right? Then if we try to take the arc sine of both sides, the arc sine of the total equation, sine of x over 2 equal to 1 over 5 close bracket. If we try to expand this one, okay, the arc sine of x over 2 will be x over 2. Okay? Actually, this cancels. Right? And the arc sine of 1 over square root of 5 will be the arc sine of 1 over square root of 5. You got it, guys? This one here emanates from this. Okay? Sine to the minus 1 of sine of x will be equal to x. Okay? It's just the reverse of this one. Okay? So, this will become x over 2 on the left hand side. How I still on camera? Equal to. The right hand side, we will take the arc sine, right? So, sine to the minus 1. 1 over square root of 5 is, this is 0.4472 by using our calculator. Okay, like what I said, this portion here is actually an angle. An angle. It will be something like this, pi square root. We take the reciprocal, then we will compute for the angle, right? So second function, angle. The angle is 26.56 degrees. So the arc sine of 0.4472 will be an angle. It is 26.56 degrees. Okay, so x now will be 26.56 times 2. And the value of x is actually 53.13 degrees. Right? This portion here. This is 53.13 degrees. Okay, we computed it is 53.13 degrees, and the problem is just asking what will be the sine of 53.13 degrees. So sine of x, okay, is actually sine, but x is actually twice this, the given problem, right? We just represent it as simply x. Sine of 2 arc cotangent of 2, as per our computation, this value here is 53.13 degrees. So if we try to take the sine of 53.13 degrees, this is multiplied by 2, right? That's 53.13. And if we try to take the sine value, it is 0.8. So the answer here is 0.8. So meaning to say, the sine of the open bracket twice the arc cotangent of 2 is actually the sine. As per our computation, 2x is 53.13 degrees. So it seems the problem is asking what will be the sine of 53.13 degrees. And if we use to take the value of this using the calculator, the value is actually 0.8. That's okay. That's it, guys. This is just one illustrative example on how to solve an inverse trigonometric function. Okay, so at least we know this concept here. There are 6. I just didn't place the cotangent, right? The cotangent of arc cotangent of x will just be simply x. So we use that one over here, right? Because there are 6 trigo functions. So the inverse are also 6. I just wrote 3 here. And the other concept that we will be needing here is this one. That is the arc sine of sine of an angle will just be simply equal to that angle. It is the reverse of this one. This one, the cosine is ahead, but on this one, the arc, the inverse function is ahead. The inverse function of any sine function is just simply x. That meaning sine to the minus 1 of sine of x will just be simply x. Okay? Okay, that's it, guys. We are almost done. Maybe I will add up 2 more lessons on the example problems using inverse trigo function concepts. Okay, so for those of you who would like to watch my channel, okay, my channel is at youtube.com/@proofdvj_. If you want to share it, please click share. I am assuring you, you will get something from it. You will learn trigonometry. Okay, good morning from Los Angeles, Professor David.